Hello YouTube viewers, welcome to my channel S2T. In today's show, Rocket Monday, today we're going to talk about ISRO's RLVTD. So let's dive right into it. Well, first we have to understand what the heck we are talking about. We are talking about test of an idea. Idea is that basically India wants to create its own reusable spacecraft. Now, core aspect of this is that it has to be made in India 100% of the time. Because while India does have a giant military presence and the fact that we have one of the few best weapons, it's just they're always done in collaboration with either Israel or Russia or some other partners. This time, this is like 100% indigenous. It's like we're gonna make it, and this is gonna be our own. So that's the base behind it. Like we want to do something, it requires a lot of ideas, so we need to build a test system now, and it all has to be done in India. Now that is why it has TD designation at the end of it. That means technology demonstrator. Think of it this way: same way Mangalyaan was a technology demonstration for India's space division to say, hey, we can actually go to Mars and we can actually place something in orbit, and we did it in one go. So same way that was a technology demonstration for ISRO, this is the technology demonstration for an idea that India wants to develop. So we have to test it before you do anything. So that is why this whole project is there. Now, why exactly this project was made is basically, think of this way. We want to achieve what we call reusable launch vehicle. That is the designation RLV. Now, RLVs are idiotically complex, super complex, complexity beyond belief. Many people wrongly assume that, SpaceX is the reason why anybody is thinking about a reusable vehicle. First, space shuttle was a reusable system. It actually reused. It was just not efficient enough. It was not cheap enough, so to say. And even before that, many people wanted to make a rocket that directly go up and went down. And Douglas Aircraft Company actually managed to build that, a test bed of that. So reusable was something that everybody wanted to do, but technology was not refined enough, not cheap enough. That, even if you could do it, it was like so expensive. Like in case of space shuttle, $1.5 billion per launch. They're like, yeah, it's no point. Just make a use and throw a rocket. It's more cheaper. So to understand the complexity, you have to handle each and every aspect of it, every single thing from avionics to computer controls to aerodynamics control to thermodynamics to your heat shield. Everything you have to test it out. So that is why, because it needs so many independent technology. It's not just that, oh, it's a rocket. It has to have a way to fight against atmosphere. Now atmosphere is not an issue when you're going up, because once you actually start to fire your rocket and actually starts to gain your speed, again there is a shockwave in front of you, but that shockwave loses its intensity. So you go through max q, basically maximum dynamic pressure. Once you crosses that point, it's like no, smooth sailing. Heck, you ditch your basically payload fairing, because it's not no longer needed. Now when you're coming back, energy cannot be created nor destroyed. So what's exactly happening is that all the energy you put into your payload using your rocket, you have to remove it. So basically, if this puppy went up there, that means a rocket put it up there. So during landing, it has to remove that energy. Basically, let's say you put 10 megawatts of energy into that, pushing it up there. Again, there is a calculation for that if you want to do it. To remove that, you have to somehow dump that amount of energy, and that's no small feat. That's a rocket energy. So people generally use that energy in a form of heat. Basically, we apply friction braking through the atmosphere. You're just like, let the atmosphere sip away all the energy. Now doing so not only makes it very hot, it makes it extremely dangerous, because you have to have a thermal protection system that can handle that. You are talking like almost like a rocket nozzle directly pointing at you, and this is not only hot, it's very reactive and volatile. So in those things, sort of scenario, you have to make sure that you can maintain stability. You cannot even have a scenario where you start vibrating a little bit, because if you start vibrating at those temperatures, yeah, you did. So ISRO has had four major goals that they're like, dude, we're gonna do this and we're gonna figure out whether we can do this or not. So first was hypersonic aerothermodynamics. What does that mean? Think of this way: once you are above the atmosphere, once you are traveling at quote unquote orbital speed, during re-entry, you're gonna go very high speed, like very high speed. I'm talking like Mach 5, Mach 10, Mach 20, those kind of ludicrous speeds. So generally they are classified as hypersonics. So any control surface you have, basically winglets, aileron, or anything like that, those must work at those high temperatures. And you have to understand that it's not only temperature, you also have to manage it. Basically, you cannot be like, oh, move the wing like this. You're gonna spin the craft up, because dynamics change. Because how your steering wheel, you only need little bit if you're traveling fast. If you're traveling slowly, you have to do like this. But when you are traveling like very fast, you're like little bit. So same happens here. So hypersonic is a thing that not every Tom, Dick, and Harry knows about it. And not every avionics company can handle it. So we have to test it out whether we can actually manage it. Then thermal protection is like, rocket put the energy in it. We have to remove the energy in it. So thermal protection is the first line of defense. Then guidance and flight management is also there. Now guidance is also important because while you're coming down, you're getting basically a blanket of plasma. A problem with that is that blanket of plasma cuts off any radio communication. Interference becomes so damn high that it's impossible to communicate. And if you have seen any movies relating Apollo missions or even space shuttle, you've seen once they go through that atmosphere reheating phase, flat out all communications are cut. Like until they come out of that plasma ball, they cannot be communicated with. That's why NASA is developing into X-ray communication. In principle, X-ray can punch through that, but so far it hasn't been, like, again, it's still in early testing phase. So as of now, the craft, while it's coming down, it has to do all the calculation on its own. It does not even have the luxury, hey, I'm going to communicate to that satellite, do this and all that. No, it's 100% on its own. So it has to know how the heck I'm going to manage myself and where I am, how the heck I'm going to track. Is my internal gyro systems are reliable enough? Flight management, because once it's out of there, it has to align it. Like, think of it this way, airport seems big to us, but from a plane's point of view, it's like a narrow line that you have to land. It's a very difficult thing to do. So this puppy has to do that while it's traveling at hypersonic speed, aim itself correctly, because if it does not aim itself correctly, it does not have engines. It's only one shot to align itself properly. Failure to do so, yeah, it's dead. So that is why all this complexity needed to be tested out before we are, like, start putting expensive satellites into that. Now again, it was launched in May 23rd 2016. Yeah, I'm a bit behind that. But again, it was launched on a solid booster HS9. Basically, it's a toned down version of this booster because this booster was too powerful and they had to tone it down because otherwise the G-force could damage the craft itself. Again, this craft is made for light payload, not ICBM loads. So they had to tone it down. Now it achieved the speed, the maximum speed, Mach 4.8, and maximum altitude was 64 kilometer. Unfortunately, that's below carbon line, so technically it's not a spacecraft, but you get the idea. So they put it, they launched it. Now everything went accordingly. They launched it. Basically the solid booster ran for 91 seconds, and then it coasted because it's a ballistic trajectory. If you are putting so much energy, even if you cut off your engine, and the fact that atmosphere is starting to thin at this point, you will still keep going up very far. So cutoff could happen as early as, let's say, 40 kilometers. You can still coast to 20 kilometers more. So 40 kilometers your rocket shut down, at 60 kilometer you will actually start to fall down. So that happened with this. So the peak altitude it reached is around 64.5, or basically 65, and then it started to re-entry. Now because you are falling under the gravity and you have that ballistic trajectory, you're gonna go fast. Now generally the thing that stops you from going ludicrously fast is the atmosphere, but at 65 kilometers up, there is not that much of it. So you actually end up in a hypersonic regime. The moment you hit the atmosphere, the thicker atmosphere, that is like, let's say, 30 kilometers, boom, you're like directly is going into furnace. So that was the testing of the thermal systems. Can the thermal system handle it? And during that, it has to correct itself. It's like, dude, I have to go there, I have to do that now. I do not have, like, oh, I'm gonna circle around. There is no circling around. I have to do that now in one go. Testing all of that. And in computer they simulated basically, quote unquote, a virtual runway that's supposed to be somewhere in the ocean 10 kilometers. Again, the exact spot was programmed into the computer, and they checked how accurately it comes and actually manages it, because it's never gonna be like, you never see any plane landing like exactly in that white line in the air, and it's always in the runway. So they did that. This all happened, everything went accordingly, it was successful. Now then we come to the most overhyped and misinformed aspect of it, that is Indian space shuttle. First of all, no, nobody is building a space shuttle. Space shuttle was a bad idea. No Tom, Dick and Harry is doing it. The whole reason why India is doing this, basically building something like this, is simply because a test bed. This is the easiest way to test out your thermal technology. This is the easiest way to test out your avionics. Can it handle that? So that's the reality of it. Nobody's building a space shuttle. India is building a Gaganyaan, which will soon carry Indian astronauts to space. This is a normal capsule design. Nobody is building space shuttle simply because space shuttle is inherently flawed. It does not allow any escape system. Yeah, so even if, let's say, in case of BFR, that will be the another issue. How the heck they're gonna get human rating? Is that if you put something on top and it's that big, like almost a second stage, how the heck you're gonna pull people away in case of a stage one going boom? You cannot do anything if that happens. That is why Dragon has a launch escape system, and even Gaganyaan already tested for launch escape system, and every Tom, Dick and Harry has launch escape system, but you cannot do launch escape on a shuttle design. It does not matter whether it's on the side of a rocket or on top of a rocket. It cannot be helped. It's too big, too heavy. You might as well fire the second stage boosters itself to move yourself away. But so far, I do not think that can be done. So That is why India is not building this for a manned mission. They have already, like Gaganyaan is already built, it's already been launch tested. So I have no idea whether that rumor came around. Now the core reason, even ISRO's own web page, where which I have linked provided line where it's like, dude, this is a testing ground, we're gonna test things out, we have to understand whether if we design a plane that can handle hypersonic speed, can it actually handle that. So that is why India built that. Like, they are very clear about it. It's just that overhype of media and all that jazz made it kind of messy scenario. Now, what can we expect in the future? Now, ISRO is gonna soon in upcoming years gonna go through a tough spot. Now, what does that tough spot mean? Simply because ISRO is getting a lot of funding from government. Again, it's a government organization. Majority of its funding is coming from the government. However, again, India is rich, well, not that rich where it's gonna compete against NASA. So ISRO has to do some other works, which generally includes launch satellite service providers. Basically, we're gonna launch satellites for other countries, and it has been quite successful, very successful. It is so successful that launch costs of Indian satellites are very low. However, at this point in time, even though ISRO can smoke 100% of countries' national agencies, the private company is a different game, because SpaceX, they are not thinking about reusable rocket, they are utilizing reusable rocket as of now. So their launch costs are already coming down. On top of that, SpaceX was not allowing CubeSat launches as a primary objective. They were like, we're gonna launch it main thing, and only governments were getting, like Department of Defense was getting, like, yeah, we can add some extra things. Soon SpaceX will also open the service where they are launching, if they have the Delta V available to the rocket, they are like, yeah, we're gonna launch your CubeSats also. That drastically reduces the cost. Their rockets are the cheapest already, and if you don't even have to pay the majority cost of something, the secondary cost is way too low. Those flat out CubeSat market is gonna be taken from SpaceX. On top of that, there is another company known as Electron Rocket Labs. Basically, they are developing a rocket that is much more expensive than a SpaceX one. However, it is quick. So what does that quick mean? Think of it this way: you came up with the design. This is a CubeSat that I want to launch 100 of that, but before you launch 100 of that, let's say even if you want to do 100 launches, ISRO have already that world record, 100 satellites in 100 CubeSats. So you have to test it out in space. So what the heck you gonna do? You're gonna send to SpaceX? No, SpaceX like gonna be like, yeah, we have to wait until the other slots fill up. You're gonna go to Rocket Lab, Electron Rocket, and Electron is like, I got this. It's more expensive, but it's quick. So you call them up, it's like, yeah, next week we have your delivery, space delivery. So ISRO is getting attacked on both sides. Now ISRO is not Department of Defense. Even basically, India has own department known as DRDO. So DRDO budget will never be affected. However, ISRO's will be. So ISRO has to maintain its cost competitive advantage. It already has advantage, like a much more advantage compared to basically ESA and NASA, but it has to compete against private individuals as well. So making a reusable rocket no longer is a, oh, nice to have. It's a must to have. Then what can be done with, let's say, RLV? Let's say because RLV, the design was done very long ago. It built it's a government project. Even though it's more efficient compared to any other system, it's still bureaucracy, so it's not going lightning speed. So RLV can be made into something useful. Absolutely, the most useful thing right now is Air Force of America has is X-37B. Now this is a space plane, quote unquote space shuttle. Now this has almost the same dimension as India's system. Now the reason why this is so amazing, it is launched on top of a rocket. Now it actually goes to the orbit, not below ground. It's like full orbit is achievable, and it also has a small rocket engine which has a hypergolic fuel system, so it can actually maintain orbit. So even if you put in low Earth orbit, where like drag will fall, make sure it falls very quickly, it can maintain its orbit. Now this system is loved by basically government agencies all around the world. Again, they wish to have it, but only USA has it so far, or maybe other company has better one and nobody has leaked it yet. So the benefit of that is, like, let's say you want to build a spy satellite. You built a very good optical system which allows you to zoom in very close. Again, how the heck you gonna know whether it can actually compensate for space distortion? Basically, when you're moving through space, the atmosphere, like you are talking about 100-kilometer atmosphere, how the heck you gonna compensate against that distortion? You test it. That's the only way. You just bloody test it. So this puppy has that. This has payload door, and you can have your camera pointed out. And this puppy, because it's unmanned, it can stay in space for upwards of 2 years. That was its last mission. It can remain there. So even if, let's say, somebody say like, hey, for Department of Health, we have this magic black solar panel which allows your satellite to be much more discreet, so no, let's say your enemies cannot detect it. Awesome. But again, do you know whether this system will work amazingly well in space, because lab testing is good enough and all that jazz, but it does not even come close to space. So you can literally put it inside it and just test it in space, and if something faulty happens, no problem, you just close the door and come back in and check it again. So it is amazing. So if India pushes with the RLV and just that whole RLV, and they upgrade it to stage 2, this can be a really big game changer. However, in case of ISRO's itself, their mission goal when at that point of launch was like, we have still 15 years of work left. So in next 10 years, when I'm making this video, they're gonna like announce what exactly they're gonna do. There are some multiple projects in the works, which includes ramjet engines also. So there's a long way to go yet. So this was my presentation on basically ISRO's a reusable launch vehicle. I hope you liked it, learned from it. In that case, please click like the button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me an extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.